Hello, everybody. Two companies, actually. Last year it was Causal, and a long time ago it was a company called Akunu, which was one of the Cassandra companies. But yes, now I am VP Product at a company called Grafana Labs. Who here uses Grafana? Okay, not too many. Who here uses Prometheus? A few more. So the people who are using Prometheus who are not using Grafana, put your hands up. What do you use? Nothing. Okay, interesting. Like I think nowadays it's considered Grafana to be kind of the de facto dashboarding solution for Prometheus. Anyway, so today's talk is going to be about Prometheus and Kubernetes and then how they combined and how best to use them together. There's quite a lot of content out on the internet about this, so I'm going to try and deep dive into a couple of particularly useful queries and dashboards and not give perhaps the really general wide view. I've got some links to some really good presentations at the end that give a much more general view. So for those that aren't familiar with Prometheus, Prometheus is a monitoring and alerting system. It is not a time series database. It has a time series database in it. It was built by some chaps at SoundCloud quite a long time ago now. But for a very long time, it's been open source. It's a proper community effort. It's not owned by any single company. I'm one of the Prometheus developers. Bjorn, another one of the Prometheus developers, was actually in Lviv 2 weeks ago, apparently. A lot of the Prometheus developers are in Berlin, but there's about 20 of us, and we're spread all around the world, affiliated to all sorts of different companies. It's a really good project. So Prometheus was inspired by Google's Borgmon. Google's Borgmon is one of Google's internal monitoring technologies that they use to monitor their services running on Borg. Borg is Google's internal cluster scheduler, which kind of begat Kubernetes. So you can see how Prometheus and Kubernetes are both kind of inspired by complementary technologies inside Google. So what makes Prometheus cool? Well, it's a simple text-based metrics format. This has since been spun out into a new open source project called Open Metrics. And this text-based metrics format makes it really open, really easy to implement. You can emit it just from a bash script if you really want to. And other vendors are starting to adopt Prometheus's text-based format, which is awesome. Like Influx, Google, other vendors are using it. And so really we're trying to push it as the de facto monitoring instrumentation library, effectively, instrumentation standard. Prometheus has this multi-dimensional data model. So for people who come from perhaps the graphite world, where your identifiers for your time series are hierarchical strings, Prometheus kind of encourages you to this label-based multi-dimensional model, and I'll go into a lot more detail about that in a minute. And then one of the things I really like about Prometheus is its query language. We've not tried to copy any other query language. We've not tried to, model it on SQL or anything like that. It's a very simple, very concise, and very powerful query language, and we'll give you loads of examples of that. So a couple of, people tend to get a little bit confused about Prometheus. It's not for logging. It's not for events. It's really just for metrics. Really focused, really simple. We focused on a really simple execution model, an operational model. So it's a single binary. You run it on a server. That's about it. It also works incredibly well in highly dynamic systems. So if you've got a Kubernetes cluster with pods coming and going and moving around and being dynamically scheduled, Prometheus can keep up with that. It integrates with Kubernetes at the service discovery level and will track pods as they get started and stopped and new ones get launched, and will start scraping the metrics from them. Last fun fact about Prometheus is it was the second project accepted into the Cloud Native Compute Foundation after Kubernetes, which kind of gives you some impression of the relationship that they've got. So what does Prometheus look like? Well, it's a collection of components, the main component being the Prometheus server in the middle. But we'll start from the left and work our way right. We've got your jobs, which tend to be, you instrument them with the Prometheus client libraries and expose metrics about your job's behavior. So we'll get into what those metrics might look like in a minute. But this is the first key distinction about Prometheus in that it's a white box monitoring system. The expectation is you're going to come along and instrument your applications so that they expose Prometheus metrics, and you're not just going to measure things that you can read from the environment, like CPU and memory. Right, so the reason we're going to do white box is because we can get a lot more fine-grained information about your application's behavior. That being said, there's a whole bunch of what we call exporters in the Prometheus world, which allow you to gather things like CPU, memory, disk, network, you name it. Literally, there's an exporter for everything. These exporters also act as adapters between other monitoring systems and Prometheus. So let's say you've got MySQL that exposes metrics in its own favorite format. The MySQL exporter will translate those into the Prometheus metrics for you. So then we move on to the Prometheus server in the middle. So the Prometheus server will use service discovery, as I mentioned, so with this example, Kubernetes, to find all of the applications in your infrastructure. We'll go and connect to them and scrape the metrics from them. And so this is the second big differentiator with Prometheus, is that it's pull-based. It pulls metrics from your applications. If you're familiar with things like Graphites, that's a push-based system. Your applications push metrics to Graphite. So the reason we prefer pull-based is kind of multifaceted, but first reason is it's very hard to overwhelm a Prometheus server. If you spin up too many applications and you start to overwhelm the Prometheus server, it can control the period at which it gathers metrics. So it can back off. So it gives us this kind of fail-safe method. The second reason is because we've got this service discovery, we can go and gather lots of really useful metadata about the targets that we're scraping and add that metadata to the time series. So we can put the name of the job, obviously. We can put the host that job is running on. We can give you its IP address, its version, you name it. Any metadata about the target that's available to our service discovery system, we can push into the time series database and give you a lot more context when you're building queries. And there's another reason. The third reason we like pull-based metrics gathering is because you can run multiple Prometheuses. Because the Prometheus is initiating the connection, there's no problem with having two of them. Or if you're a Prometheus developer like I am, you can run a third one that's got your own custom changes in and test your Prometheus changes. And, if you're a monitoring vendor, you can come along and run another one and have that scrape as well. And because it's pull-based, you don't have to go and change your application every time you want to run a new monitoring system. You don't have to run proxies and things like that. So the pull-based model is a big part of the Prometheus culture. It's also a bit of a religious thing. It's a bit like Marmite. A lot of people get quite upset about pull-based models. And, they'll just have to get over it. So, inside Prometheus, you've also got time series database. This is storing the data it scrapes. We'll get into more detail in a minute. And then you've also got a query engine. So this is where you can send Prometheus queries, it'll execute them and return you the results. So the query engine is where, that laser doesn't work, is where Prometheus and the Prometheus Web UI and Grafana and other API clients can integrate with Prometheus and render those really nice dashboards you see. Prometheus will also evaluate periodic rules. These are recording rules or alerts. And the alert rules, when they fire, will fire notifications off to Alert Manager. So a common misconception with the Prometheus system is Alert Manager is not evaluating your alerting rules. Your alerting rules are evaluated by Prometheus. Alert Manager sits there and its job is to take the notifications that those evaluations create and to group them together, to dedupe them, to silence them, to route them to the correct end user. And so generally you might see in an organization lots of Prometheus servers, maybe even one per team, but typically only one Alert Manager cluster. And that one Alert Manager is organization-wide and can deal with routing and can do really cool things. The Alert Manager we have set up in Grafana Labs use the same alert rules to route to different people depending on whether it's in dev or in production, which I think is really cool. So that means when I'm on call for production, I don't get woken up if someone breaks dev. I'm actually on call right now, which is why I'm looking at my phone. And then Alert Manager will integrate with things like PagerDuty, VictorOps, email, Slack, and get those notifications to you. So I've talked about the metrics format. Here's a big page of text. This is what the metrics format looks like. I challenge you to find another monitoring system that's metrics format will fit on a slide. But it's relatively simple. You'll see metrics is one metric per line, or one time series per line, actually. The beginning is the name of the metrics, and then you've got these key value pairs which identify the labels, and then you've got the value. And that's it. You can see how you could quite easily output this from a bash script. So we'll move on looking at the Prometheus data model. The Prometheus data model is, again, incredibly simple. We've optimized for easy to understand, low surface area. So it really just consists of one of those identifiers, which is a big bag of keys and values, and then a set of time indexed values. And the time index is milliseconds in an integer 64, and the values are just float 64. That's all we support, simplest model we can think of. Again, some people get hung up on the fact that we don't do higher precision and we don't do other data types, but the reality is this is really flexible and super efficient to store. So let's give you an example of some time series. This is that everyone can read that? This is what some of the time series identifiers might look like. I reformatted the slides for the black screen, so sorry about the wrapping. But yeah, you can see how they've got a set of labels associated with each time series, and those labels are different for each time series. What you'll see here is some of those labels have come from service discovery, and some of those labels have come from the target itself. So obviously the metric name, HTTP request total, and the path and the status, that's white box information that we've got out of the job. But then the job name, Nginx, and the IP address of the job in the instance label, should be instance, not instances. Every time I show these slides, I notice a little typo. So maybe next time they'll be free of typos. So those labels have been added by Prometheus to identify the target. So once you've got all these time series, and a pretty standard Prometheus server will easily have millions of time series in it. How do you write your queries? How do you select the time series to include in your queries? So you use what we call a selector. These again look very similar to the open metrics format, which is quite useful because you can cut and paste between the two. And they basically allow you to select time series using matchers based on those keys and values. So here I'm saying, please return me all the time series for HTTP request total for the job Nginx that have a status that matches the regular expression 5 ... Okay, so this will give me all the 500 HTTP errors. What you'll notice in Prometheus is everything's a counter. We try and encourage everyone to model everything as just a pure counter. This way, if we drop a scrape, because we're rate limiting ourselves, we're not missing information, we're just downsampling. And so you can see this is the total number of requests served on each of these paths with 500 as the status code since this job started. Okay, and you might think that's not particularly useful, because it isn't right now. And what I'm going to walk you through is how to turn this data into a more useful information. So here we can see that we've had 34 queries to /home that have failed with status 500, and 96 queries to /settings that have failed with 502. Okay, so I want some context. I want to know if that's, did they fail when this job started, or are they failing now? All I've got is the count that's always increasing. How do I tell what the rate is? So effectively, I need to differentiate that number. And we have the ability to do that. So first, you can get a window over this data. So by putting square brackets 1m, this gives us a 1-minute moving window over this time series. So it's kind of gone off the slide, but you can see how we're now getting a set of values. And you'll notice in the values that you can see, they're all monotonically increasing. So 30, 31, 32, except for the one at the bottom, you'll notice 56, 106, 5. And because in Prometheus we know that the numbers are always increasing, we can detect when the job restarted because they didn't increase, and we can compensate for that. So we know the rate there. We can calculate the rate there more accurately because we know it's gone from 106 to 5, then it's got to be at least 5. Yeah, we're still dropping some information. Anyway, we apply a rate to this, and now we can see the instantaneous error rates for these two paths. So you can see there's very few errors on home, but there's quite a lot of errors on settings. And now, this in and of itself is still not particularly useful. It's kind of interesting, but is 2.5 errors a second a problem? I mean, that's really depends on how many requests we're getting to the settings page. If it's doing 1,000 QPS, then 2.5 errors is probably not a big deal. But if it's only doing 2.5 QPS, it probably is a big deal. Anyway, before we do that, we can aggregate these and subdivide them by path, because I generally, when running a nice microservice-like architecture, we're going to have multiple replicas of each service. So I don't really care about the individual replicas, I just care about the service as a whole. So we can subdivide by path, we can aggregate by path, and then we can do a binary operation and divide this by the total number of requests by path. And Prometheus will, on either side of a binary operation, will match the labels. And then we can see it's actually 100% of requests to settings that are failing, and 0.001. So what's that? 0.1% of requests to home that are failing. And so hopefully this has shown you kind of how why I like PromQL, basically. How with a relatively simple language, with only 2 or 3 fundamental operations, we've turned what is basically raw data, like the number of requests this job has served, into a useful, like, actionable piece of information, which is what % of requests are failing by path. You know, and we actually use this exact expression in our alerts and in our dashboards. Okay. How am I doing with time? Okay. That was my really quick introduction to Prometheus. Hopefully just giving you enough information to follow on what we're going to go into now. So let's talk about Kubernetes. Who here is using Kubernetes? So there are people who put their hand up for Kubernetes who didn't put their hand up for Prometheus. So hand up if you're using Kubernetes and not using Prometheus. Guy in the back in the blue top. What are you using to monitor your Kubernetes? Oh, okay, but you're going to get to Prometheus. Cool. So one of the Kubernetes founders said that basically Prometheus is now the de facto monitoring system for Kubernetes, and that he would expect every Kubernetes cluster to really have Prometheus deployed in it, which is kind of nice if you're a Prometheus developer. Anyway, so Kubernetes, well, most of you know, it's a platform for managing containers and orchestrating containers. Like some people who like to hyperbolize, talk about it as an operating system for your data center. It's inspired by Google Borg, as I said. It's the first project into the CNCF. The CNCF was founded to contain Kubernetes. And yeah, one of the things I want to focus on here is its rich object model for your applications. So one of the ways to think of Kubernetes is not as a collection of components and jobs that you have to run and configure and connect up, which is kind of interesting, but not the point of this talk. What I like to think about it really is this abstract model which you need to design your application to fit. So you need to decide when building an application on top of Kubernetes, how you're going to model your application. You know, is it going to be a stateful set? Is it going to be a daemon set? Is it going to be a replication controller and a deployment replication set? Sorry. You know, are you going to use the cron job features? And then inside a pod, you know, how many containers are you going to have per pod, and what are the different containers going to be, and how are you going to compose different pieces of your application together? How are you going to deal with storing, and all of this information, and you design your application to fit inside this object model. And because there's some semantics of your application encoded into this object model, this gives us a really good start for building alerts. Okay, and that might be a bit abstract, so let's go into a bit more details. Let's say a daemon set, for those who don't know, is Kubernetes primitive for saying, I want one copy of this pod running on every single host in my cluster. And so you'll see this is super useful if you want to run some monitoring or some log aggregation, let's say, on every host in your cluster. Or if I mentioned earlier, there's a Prometheus exporter for gathering CPU and memory information. It's called the node exporter. And now I want to run this node exporter in every single one of my nodes in my Kubernetes cluster. So I'm going to model that as a daemon set. But on the other hand, you know, we showed earlier some HTTP requests. You know, I've got a front-end service, and I might have 100 or 1,000 nodes in my Kubernetes cluster. I don't need my front-end service to be running on every single one of them. I only maybe need 30 or 40 replicas of that to deal with my inbound traffic. So then I'm not going to use a daemon set for that. I'm going to use a deployment and a replication set. So I'm going to say to my deployment, I want to deploy 30 copies of this version of this container, and it will go and decide where to put it, how many to run. When they fail, it will restart them. And when you change the image, it will do a rolling upgrade. So this is what I mean by modeling your application using the Kubernetes primitives. So as we've got this object model, we should really get stats about this object model, get metrics about this object model. And this is where the first job I'd like to mention comes in, which is the kube-state-metrics. Written by some friends of mine. It's a pretty cool job. You run it as a deployment. You really only need one of them. And it exposes some really interesting metrics. For instance, it'll expose things like the number of pods that are running, you know, what state each pod is in. It'll expose things like the number of available pods for a deployment. It'll expose the amount of space in that's the kubelet that does that. It'll expose all sorts of really interesting information, like number of times a pod has restarted. And this is really useful for encoding some of those assumptions you've made about the object model in alerts. And so you can get told when your deployments, not deploying, when your upgrade of an image has failed, this kind of stuff, by using the metrics in here, and I'll show you how to do that in a minute. So the next thing I want to talk about is something called cAdvisor by Google. This is a job for exporting per container resource usage information. So if you want to see the amount of CPU time a container is using, the amount of memory it's using, disk, and so on, cAdvisor is where you go. And this is really useful if you want to, for instance, in Kubernetes, you're allowed to specify limits on the amount of memory and CPU a pod can use. And you might get a page, this is a true story, as happened to me last week, you get a page, slow queries coming into your service, and you go and look at this and nothing seems to be broken, it just all seems to be running slow. Well, you can go to cAdvisor, and using PromQL, you can compare the CPU usage of your pod to its limits, and you can see that there's a pod bouncing off of its limits. And then you can go and either, add more pods to that service, or you can increase its limits, or something like this. And so this is really actionable information when looking at performance data. So that's kind of my overview of the different jobs you can use, the different integrations between the two of them. I'm not going to do a really boring walkthrough of like how to wire these all up and how to install them. There's some links at the end of the talk. There's great how-tos, great automation online. What I'm going to show is, with all this information, what's the kind of really interesting queries you can run? What's the interesting kind of alerts and so on you can build? And before we just dive into kind of basic those queries, I want to give you a model to think about. And so I think this might have been the talk I gave last year, somewhere else. I gave a talk about what I call the red method, which is a model for thinking about alerting. I'm going to use 3 methods here. The third one doesn't have a name yet. First one is the use method. This is where we say for every resource in the cluster, I want to have a utilization, saturation, and error rate for that resource. So utilization is generally considered to be the amount of time that resource was busy. It's quite obvious for a CPU, right? But even for a hard disk, this is relatively easy to measure. Saturation is the amount of work that resource had to do, which of course can be more than the amount of time it had to do it in. So if you're looking at a CPU, this would be load average. If you're looking at a disk, this would be your IO queues length. And errors are pretty self-explanatory. So the red method says, well, instead of looking at resources, look at services. For every service in your infrastructure, measure the request rate, the error rate, and the duration of those requests. This should be pretty straightforward. If you're running a microservice architecture, you can export this information in a white box method and alert on this. This relates quite nicely to user experience. If there's high latency, you'll measure high duration in your requests. If there's high error rate, your users will be seeing page load failures. And then the final one, which I kind of alluded to earlier, I don't really have a name for yet, but it's where you encode the expected state of the system as kind of invariants that you use in your alerts. And this will tell you if your rollouts are failing, for instance. So let's look at the use method. You can build really nice dashboards like this, which tell you kind of how much CPU is in use, how much memory is in use, and this is kind of useful for getting an overview of how long's left in the, how much resources you're using. You want to use the node exporter as a daemon set, as I mentioned. All of these dashboards that I've got in these screenshots are open source and are reusable and extendable and configurable in something called the Kubernetes Mixin, which is a project that I've been doing with Frederick at Red Hat. And it's now becoming kind of the de facto set of dashboards and alerts that people want to use for their Kubernetes clusters. It's becoming quite widely used. I think even Google's contributed to it now. So to give you an example of how you would tell CPU utilization, you'd use an expression like this. So we can see we're selecting all the time series that are node CPU mode idle. Okay, this is a counter that only ever increases and measures seconds per second, basically. Well, it just measures second, but if we rate it, so we take a differential of it, it gives us the seconds per second. Okay, and 1 second per second is like 100% free. And so 1 minus that number is the amount of usage. So this tells us how much CPU usage we've got. And we're averaging it here because, machines have multiple CPUs nowadays and so on. Saturation, that's a little bit different. We're going to use a node average. And then the load average is not a counter in this case. It is a gauge, so it's just a value that goes up and down. So we're not using the red method here. So we're not using rate. I don't know why that use method thing's on the end. That's a problem with reformatting your slides. But the use method isn't just for nodes and for hosts. You can also use it for containers. So you would install cAdvisor. In fact, cAdvisor is actually in It keeps changing. They bundled it into the kubelet, and I think they've now taken it out of the kubelet. But it's in most Kubernetes clusters, if not all of them. And this will allow you to get CPU, memory, and so on per pod. But this, you can actually start combining this with the metadata from kube-state-metrics and start doing much more interesting analysis. So one of the common things you see in Kubernetes is that every pod within a service will have some label that unifies them all. So you might add an app label that says, like, this is the app front end. Inside Grafana Labs and most of the clusters that I've worked on, we use the name label instead of the app label. But when you look at the pod name, it tends to be different. It tends to contain some random information and a hash of the config and so on. So grouping pods by their name is not that useful, but maybe grouping them by one of the labels is useful. Unfortunately, cAdvisor doesn't know the labels, but kube-state-metrics does. So what we can do is we can use a query like this, and this is where we like, wow, mind blown, right? You can use a query like this to join label and CPU usage. I'm not just going to leave that up there. I'm actually going to give you a bit of a demo of how that works. So everyone can see my screen. So first off, this is CPU usage by pod name and namespace. And so you can see a bunch of pods. I think this is one of our internal clusters, so it's not public information, but it's fine. You can see all the pods. We've got a lot of pods running on this cluster, and you can see their CPU usage. Now, it's not really useful to aggregate by pod name, because as I said, like, look, these two pods are part of the same service, but have different pod names. So what we really want to do is like aggregate them together by effectively by service name. So let's pick out this thing here. And what this is doing is getting all of the pod labels. I don't really want the graph. It's getting all of the pod labels, and each one is a time series, and the value of that time series is always 1. Okay, and you might think that's a bit of a weird way of doing it, but what this allows us to do is multiply these two queries together, and the one will just, cancel out, and then we'll get a time series that contains both the label name and the pod name. So you can see here's all the labels on here, and like there's a huge amount of metadata. So what we're going to do, actually, let's see if I can do this without looking at the cheat sheet. It's always good to test yourself. So we're going to do multiply on pod name and namespace. So this is telling Prometheus that the label pod name and namespace is common on both sides and should effectively be joined. This is like the join parameters in your SQL clause. And then we're going to say group left label name. So what this is saying is I want to take the label name from the kubepod labels, and I want you to add it to the time series for container CPU usage. And it worked. Someone think I've done this before. Okay, but this is still, there's a lot of information, and we still haven't done the final aggregation here. So we're going to do sum by label name space. I've got to put another. Now, where's this gone wrong? 1, 2, 3. Too many, there we go, too many brackets. So we've now taken that final result and aggregated it by the label name, and we can see now basically the amount of CPU each service is using, and at this point it might be useful to show a graph. Except we have to run the query again. This is the experimental explore view that we've just launched in Grafana. So it allows you to do these kind of ad hoc analysis against your Prometheus without having to build a dashboard. It's pretty cool. It's in the latest Grafana release, which I think is 5.4. Although I actually don't get that involved with Grafana stuff. There's some really good videos online. And now we can see that the most offensive job is the ingester by CPU usage, which is kind of useful to know. And you can see how maybe this is looking a bit complicated if you've not seen PromQL before, but this is a really simple query. If you had to rewrite this in SQL, it would be huge. Anyway, let's carry on. So that's how you get CPU by service with Prometheus. Final thing, red method. Oh, not final thing, second to last thing. These are quite interesting because every single component in the Prometheus, in the Kubernetes system, all of the different jobs, all expose Prometheus metrics. So they all expose things like the requests they're processing and how many of them have errored and so on. So here we're looking at the request going into the Kubernetes API server, and we're grouping it by resource and error code, just like I showed you earlier. That's useful, but one of the things to note about white box monitoring is the monitoring tends to sit above the transport layer. So you tend to use like a HTTP middleware to monitor each HTTP handler, and that will miss transport layer errors. And so the best way to actually monitor transport layer errors is to monitor the clients. And because most of the Kubernetes components are written in Go, most of them use Kubernetes Go client libraries, they all expose the same metrics. So this is really cool. You can actually gather metrics from everything talking to the API server, ask them if those requests are succeeding or not, and get transport level errors. And this is probably the single most useful alert I've had when building a Kubernetes cluster, because this will tell me if my certificates are broken, and certificates are the bane of building any Kubernetes cluster. So here you can see this is basically the same as the query I walked you through. We're looking at REST client request total for anything that's not a 200. And then we're dividing it by all of them, so we've got a relative measure, because I don't want to look at anything absolute. And untizing it by 100, because I'm including this in an alert rule, and I want to not do that conversion. But yeah, this is also part of the Kubernetes Mixin, so you don't have to take photos. Now finally, the method that doesn't have a name yet, suggestions on a postcard. This is where I want to build invariants that tell me if my system is behaving as designed. And so, like, if I want to know if my deployments are working, I might compare the number of replicas I've asked for to the number of replicas that they actually have, which is super simple. That's the first query. This will tell me if when I deploy a pod, a new image, that rolling update might fail, and that alert will fire saying that there is not the right number. And it's a really high-level alert. Like, people always say you should be alerting on user experience. You should be alerting as the highest level possible because it captures all multitude of sins. Well, this will capture so many different problems with deployments. And you can do a similar thing for stateful sets. The final one down there tells me if my pods are restarting too quickly. You know, one thing that's quite common in a system like Kubernetes, which will effectively babysit your pods for you and will restart them if they fail, you kind of might not notice if your pod is crash looping. You know, maybe it's not crash looping all the time. Maybe it just fails every 10 minutes. You might not notice that. So this alert will tell me if the pod is restarting too often. There's more. This alert will tell me if a pod has failed to start at all. You know, maybe you've given it the wrong arguments. And the final one down here, this is how you take a relatively complicated concept. Like Kubernetes is supposed to run on multiple nodes. The reason you run on multiple nodes is because you want to tolerate node failure. But if you've come along to your Kubernetes cluster and given all of the jobs resource allocations, and you've allocated 100% of the resources in your cluster, when you have a node failure, there's no place for those jobs that were running on that node to get restarted to. So I want an alert that tells me if there's 100% utilization in my cluster, basically. I want a job that tells me if the free resources in my cluster aren't big enough to tolerate a node failure. And that alert down there, which basically says the ratio of used resources to total resources is greater than the ratio of 1 minus the number of hosts to the number of hosts. If that's true, send me an alert because I've over-provisioned my cluster. So this is kind of powerful, and again, all of these are part of the Kubernetes Mixin. Final shout-out I wanted to mention is a project called Cortex, which I'm one of the lead developers on. This is building a horizontally scalable, highly available version of Prometheus. It's recently been accepted into the CNCF sandbox. So now I'm a maintainer on 2 CNCF projects. And yeah, it's pretty cool. Like, I'd love to check it out. It's really early. It works. We've been running it in production for a while now, but it's not very friendly yet. You know, it's designed to power, Prometheus as a service generally. So I'd love feedback on this. So if you want to get started on any of these and you think any of this stuff looks interesting, here's a bunch of links that you can go and look up. The easiest way to get started with Prometheus is the Prometheus operator, again, by the chaps at Red Hat. It's a really easy way to install a fully working Prometheus system. This includes the Kubernetes Mixin that I've mentioned. If you want to do it the hard way, do life on hard mode, then you can try my Ksonnet library. This is how I provision Prometheus and Grafana and Alert Manager and Node Exporter and all these different components. This is an extensible and configurable language for describing your Kubernetes objects. It's super cool. I encourage you to check it out, and it's very similar to how Google internally manage their Borg jobs. And then finally, yeah, the Kubernetes Mixin. This is a collection of alerts, dashboards, recording rules designed to work on pretty much any Kubernetes cluster, designed to be really flexible, and will give you all of the goodness and, and many man-years of effort that have gone into designing the perfect recording, alerting and dashboards for Prometheus, for Kubernetes rather. So if any of this has been interesting to you guys, then I encourage you to check out the Google SRE book. There's a second and maybe even a third one now. It's really good. The red method, for instance, that I talked about is really just the 4 golden signals that Google talks about without one of them. And then if you want to go into the nitty-gritty of all of the different jobs that you want to use and what metrics they expose and how to deploy them, I encourage you to watch Bob Cotton's talk from KubeCon, and he gives a really good introduction to all the different moving parts and goes into a lot more detail than I was able to. And then finally, no monitoring talk would be finished without a call out to Brendan Gregg's website. The use method is awesome, and his website that describes how to use it is absolutely fantastic. And if you've got any questions about performance monitoring, that's where you should go. Cool. Thank you very much. Any questions?